Sorry for the delay in getting started, but they re-imaged the computers and whatnot, so getting everything set up, and then of course I forgot my mic and whatnot. So, okay, so let's talk about what we're going to do today and what you all are going to do between now and next Wednesday. So, like I said, we're going to spend a significant chunk of the class this semester talking or doing FE exam review. And so today we are going to begin that exam review series starting with one of the biggest topics on the exam, and that's math, okay? It's the first topic on the exam, and it's a big one. Now, I want to show you all a couple of things that I've done to Blackboard here recently so that you all are aware. So first off, if you go to course content, a couple of things that you'll see. So there's the syllabus. I went ahead and uploaded that. And then I also have in here exam review materials and exam review quizzes. If you go into the exam review materials, you're going to see a couple of things. I have a link to my NCEES, so that is where you all will create an account with NCEES for when you plan to take the exam. I have that link there. I have a link to the YouTube playlist where I'm going to collect all of the FE or exam review videos onto a collected list. This is going to be the one that you refer to the most. This is the most up-to-date version of the reference handbook. So this is where all the formulas and equations and all of that stuff is available. I have the civil exam specs, which I'm going to pull that up now because I want you to see what it is that's going to be on the exam. So if you've never seen this, this is the outline of topics that will be covered on the exam. So today I'm going to cover topic number 1, which is math. Now I'm not going to take this one topic a week. Some of these topics I'm going to double up on because there's like 18 or what have you different topics. But some of the topics I'll double up on and do at the same time. For instance, I'll probably do computational tools with something else. So you'll be tested on math, on probability and statistics. That one will probably be a fairly quick session. Computational tools, you'll have some stuff on some spreadsheets and stuff on some basic info on programming. Ethics, engineering econ, and then we've got statics and dynamics. More focus on statics than there is on dynamics, so everybody, all you civils are aware of that. Oh yeah. Mechanics of materials, or mechanics of deformable bodies, for those of you who prefer that terminology. Materials, mixed design and stuff like that. I don't know if I'll have a specific session on that because a lot of that will sort of get peppered into steel and concrete and stuff like that. Fluids and hydraulics, so fluids and H&H. Structures, so structural analysis, structural design. Geotech, transportation, environmental, and construction and surveying. The one topic that I'm pretty sure I'm going to need help on is environmental. That's the one for me I'm a little iffy on. But if necessary, I think I can do all the others. So that's sort of the plan. Let me talk a little bit about what else is on Blackboard, specifically the quizzes. Okay, now first off, so the way this is going to work is I have a quiz, and I'm going to assign a quiz probably once a week for a good little while. Now, I'll go ahead and tell you a little bit about the math quiz. So the math quiz is 10 questions, and it's 30 minutes, okay? And that is pretty much about, a time frame that you're going to get on the exam. In terms of difficulty, I will say, honestly, that the math quiz is probably moderate. Like, it's not too hard, it's not too easy. Some questions you'll probably breeze through, and some questions you'll have to put your thinking cap on. In terms of format, there are multiple choice questions. There'll be one question per screen, and you can save your results and go back and forth to screens, but it is timed. It's 30 minutes, and once 30 minutes are up, it's up. So now let's talk about grading. I am not going to assign you a grade based on your performance. I'm going to assign you a grade based on whether or not you do it, okay? So you can do the quiz and get every question wrong, and I'm still going to give you credit for doing it, okay? So I just want to see you do it. Now, if you all want, you can, one of you can do it, and you can get the answers, then you all can share that. But that's not going to do you any good, okay? I really want you to give this an honest shot, okay? Do the quiz, see how well you do. Bless you. This is meant to give you an idea as to what you need to review further for the exam. The there's 10 questions, but it goes from algebra to differential equations and everywhere in between, okay? So it's meant, this is for you to self-evaluate your abilities, okay? So give it an honest try. Go to the library, go to your apartment, go home, wherever. Get yourself a nice, quiet spot. Give yourself 30 minutes and give the quiz an honest shot, okay? Sound good? Now, before you do that, what we are going to do today, together, all of us, is we're going to do some problems, okay? Now, what I suggest that you do is that you pull up the reference handbook, okay? Now, I told everybody to come to class with the laptop, because when you take the exam, it's going to be on a computer, okay? And so the search function is going to be available to you when you take the exam, like for us, like Control F, and you can search for words and whatnot in the document. You can do that on the exam. So honestly, like when we do problems, if you're having trouble finding something, hit Control F. We used to get hard copies of this book when the exam was paper-based, and like when we would do FE review, we'd make everybody bring them, and they'd all have to look stuff up. And actually knowing the organization and content of the document was incredibly, incredibly important. But honestly, since it's a searchable PDF, I don't really like it, but it's really not that necessary. If you can hit Control F, I think you're good. I do think you need a general understanding of the document and where stuff is outlined and so on and so forth. There is a section purely for civil engineering, and so when you get to later portions of the exam, you're probably going to be living in that section for a while. But for the first part of the exam, you might be hopping around. So just be aware of that. Let's get into it. Woo! All right. So for math, it seems like it says there's only 4 areas that are covered on the exam, but honestly, this is a lot, because analytic geometry, calculus, roots of equations, and vectors, that's a lot of math. Because that calculus, for instance, that covers derivatives, integrals, differential equations, all of that. Analytic geometry, that's basically geometry, trig, all of that, even some pre-calculus stuff. The roots of equations, roots of equations is one of the fundamental tasks in algebra, so that's your algebra. And then you've got vectors and linear algebra in there as well. So there's a lot of stuff in here, but I think the big thing I want to get across is that the exam is not hard, it's just long. They don't ask you hard questions, they just ask you a lot of them, okay? So if you take each question one at a time, I think you're good, okay? Now, who brought a graphing calculator? Shame on you. Casio FX115 ES Plus or similar calculator for the FE exam, because if you have a graphing calculator, they're not going to let you take it. Now, I will go ahead and tell you that this calculator is applicable for the exam. If you go to my NCES, if you all create an account and do that, and I'm probably going to make you do that sometime near the end of the semester. I'll probably do it near the end of the semester so that you won't lose your password and whatnot. But there's a link that'll tell you their calculator policy and what calculators you're permitted to use and not. Long story short, mostly scientific calculators. They have some rules as to the brands and the names and so on and so forth. This calculator works. I do think it gives you the most bang for your buck, but there are other calculators that'll work just as well. Yeah, but like for Texas, like for instance for Texas Instruments, there's a lot of different calculators that fit within those rules. Yeah, and there's a lot of those and what have you. There are only 2 HP calculators. I highly recommend not worrying about getting an HP calculator unless you're really familiar with reverse notation, because if not, I think it's harder to figure out on the fly. So I think it's a little easier to just go about it. Any questions? Well, get familiar, because we're going to use it today. Let's get to it. So I've got 20 problems here, and these 20 problems cover the gamut. And so this is meant to sort of shake the cobwebs loose and get you all back into the swing of things with some basic math. So Let's just get started. So here's problem number one. So what is the length of a line segment with a slope of 4/3 measured from the y-axis to a point 6, 4? Okay. Does anybody have an idea of where they think we should start with this? Well, okay. Well, what does that mean? Figuring out the intercept. Figure out your b. So basically what you're saying is find the equation of the line, right? Okay. So how do you think we should find the equation of this line? Well, we know that the slope is 4/3, and we know a point 6, 4. So what can we do? Well, y equals mx plus b, but how would we determine that? Maybe y, there you go, y minus y1 equals m times x minus x1. Yeah, I think I'm starting to see some pen difficulties. Oh, cross your fingers. So y minus 4 equals 4/3 x minus 6, right? So y minus 4 equals 4x over 3 minus, okay, so what's 4/3 of 6? Or what's 4/3 times 6? There we go, 8. This is where your Casio FX115 ES Plus comes into play. Oh no. We're gonna make through. We're gonna get there. So y equals want to see something. Hold on. I want to see if anybody's in this room. Because if they're not. You need to replace the ink on these pens, let me tell you. Yeah, I know they let it set so it dried up, I'm telling you. All right, minus 4. That's awesome. Okay. All right. So pen difficulties aside, we've got something that works. Now, okay, so that's the equation of the line. Is everybody okay with that? Okay, so let's read the problem. The problem says, what's the length of a line segment with a slope of 4/3 measured from the y-axis to a point 6, 4? So we're talking about the length of a line segment. We know the point 6, 4. What are the coordinates of the other point? Well, it's from point 6, 4 to the y-axis. So if we're looking at the coordinates of the point on the y-axis, so we've got 6, 4 and something, something. So if it's on the y-axis, what are the coordinates of the x value? Or what's the value of the x coordinate? 0, right? Okay. And if it's on the y-axis, anybody know what this is? -4. It's the y-intercept, right? So this is minus 4. So here's our 2 points. How do you find the distance between 2 points? So what do you think? Amazing. In all seriousness, is that bad? I mean, that question's a little bit of work, but it's meant to sort of like shake off the cobwebs a bit. Basic graphing, fundamental algebra, all right? Well, that's what the practice is for. All right. Any questions? All right. 1 down, 19 to go. And barring technical glitches, there we go. I think we're good. All right. Okay, so problem 2. What is the general form of the equation for a line whose x-intercept is 4 and whose y-intercept is -6? Now, first off, if you don't remember what the general equation or general form of the equation of a line is, you got a couple options, okay? What's your first option if it's during the exam and you don't remember what the general form of the equation of a line is? Look it up. You've got a computer in front of you with the NCES reference handbook. Look it up. All right, so that's the, in all honesty, that is the first thing I would do. But there's also a very real, analysis that needs to be made. Does it really matter if you remember? I would say no. It's asking for the equation of a line. I've got some equations. Let's just manipulate one using rules of algebra until we find one that works. So let's just see what happens. Okay, it's asking for the equation of a line whose x-intercept is 4 and whose y-intercept is -6. Okay, so if I just wanted to find the equation of the line, y equals mx plus b, tell me what to do. So what I'm getting at is we need some points, right? If you have a line, if you want to define what a line looks like, you need 2 things. You need a point and a slope, or 2 points, right? We have 2 points. Tell me what those points are. There we go. So 4, 0 and 0, -6, right? So what do I do? You tell me what to do. Well, what I'm getting at is if we need, let me ask it this way. You want to find the slope of the line. So tell me what to write. There we go. Right? Y'all remembering this? This is the stuff that's going to be on the exam, so make sure that you're following along. Okay, so what do I write on the top? Maybe -6 minus 0 and 0 minus 4. Is that right? So I got -6 over -4, or 3/2. You okay with that? All right. And then, do we need to use point slope formula, or do we know what the y-intercept is? And what is it? -6. So b is -6, therefore y equals mx plus b, or y equals 3/2 x minus 6, right? And as for the general form, why don't I use some algebra to get this equation to look like the stuff on the choices? So why don't I take this equation and multiply both sides by 2. So here, I'm going to take the x off so that doesn't get confusing. So I've got 2y equals 3x minus 12. And then why don't I take that y and move it on over, that y term. So 0 equals 3x minus 2y minus 12. What do you think? It's not too bad, right? Any questions? Because remember, y equals mx plus b is the y-intercept. So, yep. And if you were if that didn't work for you, do point slope. Y minus y1 equals m times x minus x1, and just plug in one of the points. What do you think? Do I need to stop? Are y'all good? Well, look at each of the options. Okay, what do they all have in common? Okay, they're all set equal to 0. Okay, so that's why from this step to this step I took the 2y and moved it over. Okay, and as for how did I know to multiply it by 2? Well, there's no fractions. So the only fraction here was 2, so I multiplied it by 2 to get rid of the denominator. Yeah. That's a good question. Ask this stuff. This is where you ask. This is important. Okay? Everybody good? I'm not like some professors that's going to go rah, 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 if you start asking questions, right? That's a technical term, by the way. All right. Oh. It's like, all right. It's going to be like that, is it? Now, does your Casio do logarithms of any base? Then plug and chug. Oh, what was that? You don't remember where the buttons are. Well, then why don't we use some properties of logarithms? So we have the base 3 log. Oh, no. We're gonna do this for real. Plus the base 3. Yeah. Minus. Because what if it was the base 3 log of x? Hold on. You all gotta have more faith in yourselves. Now, stop with this. Remember this. Hold on. Everybody pay attention to me for about 10 seconds. Shh. Stop. I've got the logarithm of A minus the logarithm of B. I propose that I can rewrite that as the logarithm of A over B. Oh, yeah, bringing it back. So I have... That's search logarithms. All right. Now, okay, so that's the base 3 log of 6. Okay. Now, if I've got two logarithms that are added together, I multiply them. So these two become the base 3 log of 3/2 times 12 over 2, which is 6. So that's the base 3 log of 9. Now, does anybody remember what a logarithm is? It's just a fancy way of writing an exponent. If I need to determine what this is, basically I'm trying to figure out what power do I raise 3 to get 9. And so what's the answer to that?
What is the answer to that? Oh.
Theater majors or something? My goodness. It's only week 2. You don't have the permission to be this delirious. I'll allow that when it's week, 13 or something. All right. All right. Shh. Any questions? All right. Okay. 2. Because what this is saying is that 3 to the x equals 9, so x has got to be 2. All right, stop with the chatter and all that. Okay, so for some angle, the cosecant of that angle is minus 8/5. So what is the cosine of 2 times that angle? And everybody's like, oh no. All right. Hold on. Hold on. I'm going to show you some things that's going to bring it back. First off, y'all relax. Relax. If the cosecant of this angle is minus 8/5, what trig identity can help us out right now? Simple one. The sine. And so what's the sine? Flipped, right? Yes. Yes, it does. In fact, I'm glad you mentioned that. Why don't everybody hit Control F on your keyboards and what have you and find the trig identities? Trig identities. You should know that. Go type it. You're going to be taking the exam. Type it. All right. Everybody sit down. What I want you to find for me on this example is this. I want you to tell me. No, why don't you do trigonometric? Or why don't you search identities? Search trigonometry. There you go. Look. Everybody, everybody settle down. Settle down for a second. In all seriousness, you need to go through this process of finding this stuff. I'd rather you trip up and have some issues finding this stuff now as opposed to finding on the exam. This is the first time a lot of you have seen this book, so that's fine. But seriously, I know some of you are like, well, I'll just, let somebody find it and I'll just sort of, figure out what page you're on. No, find it yourself. Seriously. It's not for me, it's for you. So find it on your own, because that'll help you out. So has everybody found it? Okay, this is what I want you to do, okay? We know the sine of theta is minus 5/8. It's asking for what's the cosine of 2 theta. Is there an identity we can use to just directly calculate it? What's that? I know. I know. I can do that, but I'm asking for an identity. And I'm doing this so that you all get a little more familiar with the book. Like, I'm asking for this. I'm asking for an identity that says the cosine of 2 theta equals something, and it's a function of the sine. Hold on. I heard something. Say it again. That's the man right there. 1 minus 2 times the sine squared of theta. So therefore, that's 1 minus 2 times that. So that's 1 minus 2 times 25 over 64. That's 1 minus 25 over 32. So that's 7 over 32. The point of this problem was to get you familiar with the book, with the reference handbook. Can you do what Mr. Smith said, where you can take an inverse sine to it? Yeah, you can do that, but that's another way of doing the problem. I'm not saying anything about that being wrong, but I want y'all to get familiar with this document, okay? And I will say that on your quiz, there are problems where if you look at the document, it will literally tell you what the answer is, okay? Speaking of, how about this? This is one where you can't use your calculator, okay? Can I give you a general piece of advice in regards to trig identities and trig in general on the exam, okay? My general piece of advice is this. Whenever you need to do some stuff with trig, and simplifying expressions or anything like that. Get everything into sines and cosines, okay? By transforming everything into sines and cosines, you will make your life easier when it comes to simplification and doing problems. The manual provides just about every way under the sun to translate between sines and cosines. And so if you can do that transformation, you're rock solid. And so here's what I mean by that, okay? What can I do with the cosecant? So hold on, I got the cosecant of x, I've got the cosine cubed of x, and I got the tangent of x. What can I do with the cosecant? 1 over the sine. I've got the cosine cubed, whoop, getting ahead of myself, cosine cubed of x, and what can I do with the tangent? There we go, sine over cosine. Okay, so what happens with the sine functions? They cancel. What happens with the cosine functions? Cosine squared. Okay. Now, is cosine squared an answer? No. Are there any identities that we can use or that we can convert cosine squared? Does anybody remember a very, very famous identity about the cosine squared? The cosine squared plus the sine squared equals 1. So if sine squared plus the cosine squared equals 1, doesn't this equal 1 minus the sine squared? Okay. What do you think? Bringing it back, right? You feeling a little better? Feeling a little better. All right. What's that? Oh, goodness. All right, y'all relax. Okay, now I got a little bit of algebra and a little bit of trig mixed up in this problem. You relax. Cheers. I'm serious. All right, you got a little bit of algebra and a little bit of trig mixed in this problem. So I'm going to walk you through this a little bit. What value of x less than 360 degrees will satisfy the following equation? Now, I want to make a general point about this problem. Let's say you are absolutely lost as to how to do this problem, okay? Let's read the question. It says, what value of x will satisfy the equation? And it gives you 4 answers, okay? So if you're absolutely lost, what do you think you should do? There you go. Guys, look, this is an exam that requires an A, B, C, or D. If you don't know, just pick one, okay? And in a situation like this, just start plugging and chugging, okay? Just the sine square, like just in parentheses. So the sine of 45 degrees and then square the whole thing. So I don't know if there's a function for sine squared on these calculations. I don't think there is. I would just take the sine and then square it. But if you are still a little unsure, let's do the math of this. Would you agree that this is it looks a lot like a quadratic equation? So why don't I do this? Why don't I guys, my goodness. Let's let a equal the sine of x. So if that's the case, I've got a squared plus 4a plus 3 equals 0. Right? So can anybody factor that for me? Yes, you can. Everybody remember how to do that? We haven't. There we go. Right? And then, so that means that a equals minus 1 and a equals, or minus 3. Right? Or the sine of x equals minus 1, or the sine of x equals minus 3. One of these answers doesn't make any sense. Does anybody know which doesn't make sense? Minus 3. Why? Unit circle or the graph. But we're basically saying the same thing. Okay? Look at this. Remember the graph of the sine? Sort of looks like that. Remind me, what is this value and this value? 1 and -1. So that's where the curve hits -1. When does the curve ever hit -3? It never does. So this is a spurious solution. This isn't valid. But this one is valid. And when does that occur? What is that value of x? 3 pi over 2 or 270 degrees. Or you can plug and check. But I'm just showing you a couple different ways of going about this. Yes, sir. That's a good question. The question, I'm going to repeat for the recording. Question was when to put your calculator in radians versus degrees. What I would say is this on the exam, more often than not, degrees are going to be fine. If you're doing pure math problems like this, you might want to convert to radians just so that you're aware that if you take an inverse sine or you're dealing with 3 pi over 2 or what have you, that you're dealing in radians. But more often than not, degrees are going to be fine. I would also mention that later on, let's say when you're doing surveying calculations, I would almost explicitly require you to put your calculator in degree mode so that you don't have any issues with degrees, minutes, seconds, and anything like that. I'm not 100% that you're going to get an issue with that either way, but in surveying land, we don't ever really deal in radians. I would just leave it in degrees. So yeah, I know that's a little bit of a winded answer, but yeah. Any questions? Let me also add a follow-up. If you're, a lot of times the answers, like look at this, 45, 90, 180, and 270. They're clearly all degree answers, okay? If you perform calculations and you're getting like 0.26, then you're probably dealing in radians, and so that'll tell you to convert. Does that make sense? So yeah. Any other questions? This is good stuff. All right. Oh, skipping ahead. Does anybody remember how to do this? If you have the rectangular coordinates of a given point, what are its polar coordinates? Now, before we start doing this problem, can anybody tell me if any of those answers are not correct? So, yes. Exactly right. Exactly right. The first choice is not the answer because remember, rectangular coordinates are x and y. Polar coordinates are r and theta. And r is always expressed as a positive value. You go out a certain radius and then turn a certain angle. Okay? So right off the bat, that answer is incorrect. Another thing about this, this problem, we can probably do a little bit more whittling down by just looking at these choices. Okay, let's look at this. Where is this point located? Third quadrant, right? So over 3, down 5.2, something about like that, right? Okay. So this is -3, 5.2 in rectangular coordinates. Now, based on my choices, and we're starting to get into test-taking skills at this point, based on my choices, I'm going to do a little bit of a prediction, or ask you to do a little bit of a prediction. What is that distance? 6, right? All right. Now, does anybody remember how angles are turned in polar? You start at the x-axis. Positive angles go what? Up or down? Up, right? So this is positive, or this is a positive angle. This is a negative angle, right? So let's just do a little bit of deduction here, okay? We've already eliminated this answer because it doesn't make any sense. Is there any other answer that we can eliminate? C, exactly right. That one's invalid as well, okay? I want you to develop these skills as well when you're taking the exam. This happens quite a bit. You got a multiple choice question and there's 4 choices, but one of them is usually pretty off, and with a little bit of thinking you might be able to eliminate another. And so it really only boils down to 2 choices, either the 120 or the 150. Does anybody have an idea how we would determine which is which? We That's funny, and you might not be that far off. What I'm going to do is this. This is how I'm going to do this. I've got a triangle right here where this is 3, this is 5.2, and this is 6. Can somebody tell me what that angle is? How would you determine that angle? Maybe some Sakatoa, right? Some old hippie caught another hippie tripping on acid, right? Never heard that? Some old hippie caught another hippie tripping on acid. Sakatoa. Good, good. And Spring Valley? Must be a wink. So I'm going to use the tangent. I'm going to say the tangent of that angle is 3 over 5.2. So therefore, theta is the inverse tangent of 3 over 5.2. The reason why I didn't use the 6 and didn't use the sine and cosine is because the 6 was not given to me. And I'm trying to be a little bit of a purist and only use the data that they gave me in the problem and not what I think the answer is. Now I could do a Pythagorean theorem and figure out that the r is 6, but, you know. So what are we getting for theta? $30 degrees. All right? So if I wanted to turn this angle starting at the x-axis going this way, how far would I turn? 120. So I propose that that's the answer. What do you think? Did I go too fast on that? See, if this angle right here is 30 degrees, then from the axis I go 90 and then another 30, so that's 120. It would be a negative 120 because I'm turning the wrong or the opposite direction. So r is 6 just from, they're all 6, and then this is minus 120. So your logic kind of worked out, but you were lucky. Although you'd be surprised how often that happens on the exam. Well, that too. How are we feeling? Are we feeling good? Any questions? Again, this is the time to ask. No. I mean, I see where your logic's going, but if the 3 and the 5.2 had been reversed, it would be D. Like if it had been negative 5.2 comma negative 3, you could have all these choices and it would still be D. You see what I mean? So, no. I see where you're going, but yes, that's what you would do. You know your trig. Okay. All right. Now this one's ratcheting it up a bit. Okay. Determine the xy coordinates of the center of a circle defined by this equation. So this is probably pre-calc land for most of you. Now, does anybody know what the equation of a circle is? Well, that's true if the circle is at 0, 0, if that's where the center is. But what if the center is at an arbitrary point?
X minus h squared plus y minus k squared.
There we go. And now, how did you find that?
It's on page 30.
It's in the reference handbook that's in front of your faces. So you probably want to search that document to find the equation of the circle, right? Is everybody okay with that? Okay. He's right. Search circle. There'll probably be a lot of instances, but you'll find it. What's that? Oh, there's only 19 entries of a circle. Okay. All right. So the equation of a circle. Oh, I'm getting myself. Is x minus h squared plus y minus k squared equals r squared. Okay? So r is the radius and h comma k is the center. Not necessarily. Not necessarily. Mm-mm. You'll see. Now, let's deal with the x quantities first. Okay? X minus h squared. Okay? So I'm going to do something off to the side here. Okay? And it's not going to be related to this example, so just bear with me. Okay? Let's take x minus 3 squared. Does anybody remember how that FOILs out? What's that? Plus 9, right? Everybody okay with that? Yes. The air is coming on momentarily. The air conditioning will kick on momentarily. Is everybody okay with this? Okay? So what I want to do is this. I want to look at this term right here in the equation, x squared minus 8x. Okay? Now, ultimately what I want to do is I want to factor this so that it looks something like that. Okay? Now look over here. If I had x squared minus 6x, bear with me, I propose I need a plus 9. Okay? So I half that number and then square it to get this. Is everybody okay with that? Do you remember you ever heard the term completing the square? Okay. So watch this. Watch what I'm going to do. Nope. Well, ultimately, but bear with me. This is what I'm going to do. I'm going to rewrite this equation like this. Okay? And what I'm doing is I'm grouping all the x stuff together and the y stuff together. Okay? Now, I want to be able to factor this as a perfect square. Okay? So what do I need right here? What term do I need right here? 16, right? I half this number and I square it. Okay? So I'm going to add 16. But the laws of algebra tell me I can't just randomly add 16 to one side of an equation without adding 16 to the other side of the equation, right? Okay. Now, what do I do here for this, this 10y? What do I need to add? 25. So I need to add 25, but I also have to do that over here. 25, not 22. And then the only thing I have left is I've got this plus 25 that's sort of hanging out in space. I'm going to minus 25, minus 25. So summarizing all of that, I'm going to have the following. So let's deal with the x terms. Would you agree that's going to be x minus 4 squared plus y minus 5 squared? Well, what do I have on the right side of the equation? 16. So the radius is 4, not 5. And what is the center? 4, 5. So everybody see where I'm coming from there? Breaking out some of the algebra stuff you haven't seen in a while. Foiling, completing the square, x, like it shows up in some equations every now and then. So far, so good? Oh. what is the slope of the following curve when it crosses the positive part of the x-axis? Oh no. We're there, aren't we? We're in calculus land. If I want to find the slope of a curve, what do I do? He saw calculus, he's running. No. What'd you do? What'd you say? So what is the derivative of y? What do we have? Okay, all right, 20x minus 3. It's like we got to get that. We got to get the derivative. Okay? All right? Now, let's put that off to the side. Okay? Let's put that off to the side. Now, it is asking, let's digest this equation for a little bit. Okay? Let's digest this. Okay? Let's just sort of put this derivative sort of off to the side and let's read the equation. What is the slope of the curve when the curve crosses, now it says the positive part of the y-axis. I'm going to ignore the positive part. It's saying when the curve crosses the x-axis. When the curve crosses the x-axis. So what is the value of the curve when it crosses the x-axis? Like if I have a curve, if I have a graph, and I got some curve that looks, something like that, okay? What is the value of the equation when it crosses the x-axis? What's the value of the equation? 0, okay? So why don't we go back to this equation and set the equation equal to 0 and solve for x, okay? Just bear with me. Just bear with me. Like, let's ignore this derivative stuff. Here, I'm going to erase it. Let's ignore the derivative stuff. All right? So, obviously, everybody in here is an expert on solving this equation, right? X equals negative b plus or minus b squared root of b squared minus 4ac over 2a. Y'all are good with that, right? The quadratic formula. Right? Does anybody have the two values of x? So you have x equals 1/2 or x equals minus 1/5, right? Okay. So it's asking, what is the slope of the curve when it crosses the positive part of the x-axis? So which answer do we care about? The 1/2, right? So would you agree that this curve crosses the x-axis right there? And it's asking for the slope of this curve right there. What do I do? Plug it into the derivative. There you go. So we said that y prime was 20x minus 3. So therefore, y prime at 1/2 is 20 times 1/2 minus 3, or 7. What do you think? Now that one's a little bit of a weirder calculus question. It's a little more algebra based, but I was just trying to get our feet wet a little bit because now we're going to jump straight into calculus land. So everybody good with this? All right. Calculus land. What is the maximum value of the following function on the interval x is less than 0? Okay? So tell me what to do. How do we find maximums? Y'all remember how to do that? So we're going to need first and second derivatives. So let's go ahead and do that. So what's f prime of x? What's the first derivative? Right? And what is the second derivative? All right, sound good? Okay. So remind me, a maximum or a minimum, what can you tell me about maximums or minimums? What's the deal with the curve? Is there something going on at a maximum or a minimum? The slope is 0. So how do I determine where the slope is 0? Well, yeah, but I've got to find the points. How do I find the points? Set the first derivative equal to 0 and then solve for where those points are. So everybody okay with that? So I'm going to set the first derivative equal to 0 and solve for x. Okay? So 0 equals 6x squared plus 24x minus 30. I can divide the whole thing by 6, and I get 0 equals x squared plus 4x minus 5. Now, I could break out the quadratic formula, but does anybody know, can that factor? There you go. X plus 5, x minus 1. Remember, you factor your constants, so the factors of 5 are 5 and 1. Do they add up or subtract in some way to give you 4? The answer is yes. The bigger numbers, or the linear constant's positive, so the bigger number's positive. So therefore, x equals minus 5 or x equals 1. Okay? All right? So far, so good? Is there any answer that we can toss out? 1. Why can we toss out 1? That's wrong. Nice try. No, what were you going to... The interval. It says what is the maximum value of the following function on the interval x is less than 0. This is invalid. X is 1 is invalid. Okay? Now, okay, so that's invalid. Okay? Now, I'm going to walk y'all through this. Okay? So we have an extreme. We have an extreme point, or a candidate for an extreme point. But we don't know whether or not that's a maximum or a minimum, right? Remember, it's a point where the slope is 0. So the curve's either doing that or it's doing that, right? So how do we determine that? We plug it into the second derivative, right? Remember, the first derivative gives you slope. The second derivative gives you concavity. Y'all remember that? Bringing it back, right? So it's okay if it's been a while since you've done this stuff. That's why we're doing it now. So it's okay. So this is minus 5, and we get, so this is 12 times minus 5 plus 24. And what do we get? Do I have a second on that? Okay. Now, remind me, what does a negative second derivative mean? It's concave down, right? So at x equals 5, we know the function looks like this, right? And so that's x equals 5. So is this point going to be a maximum or is it going to be a minimum? Maximum. Now, is the answer minus 5? Well, on that interval, yes, you're exactly right. But my question, let's get to my question, is negative 5 the answer? You need to plug it into the original function to actually get the value. It's asking for what is the value of the function, so we plug that into the original function, yes. The concavity. If it was positive, it would be like this, and so that point would be a minimum. Yeah. That's a great question. And the answer is yes. Okay? The reason why is what if your curve looks something like this? Like what if it looks like this? Right? What if the curve looks like this? Okay? The maximum is right there. So if you do this test and you find that this point is a minimum and not a maximum, then your actual maximum value on the function might not come from a derivative test. It might just be the value right there. So I see what you're saying, but yes, you would have to. Does everybody else follow that? He was asking, well, would you really need to go through and do a second derivative test on a problem like this? Most likely not, but there is a situation where if maybe you had a weird-looking curve and you've got a local maximum that crosses the axis, you might need to compute that. Sort of, I think, was going to what you were saying as well. Is everybody okay with this? I know it's been a while. It's okay. Sound good? All right. So, but we don't have to worry about that for this problem. We know that we are dealing with a maximum, so just plug and chug. Therefore, f of minus 5 is 2 times minus 5 cubed plus 12 minus 5 squared minus 30 minus 5 plus 10. What does that come out to be? 210. So far, so good? If you all thought you had it before, I know I'm going to push you to your limit with this one. All right, so what is the value of the following limit? Now, what's your first strategy always when evaluating a limit? Plug it in. So what are you going to get on the bottom? What are you going to get on the top? That's not good, right? That doesn't tell you anything. Say it again. L'Hopital's rule. Do y'all remember that? When you get an indeterminate form, like a 0 over 0, how do you evaluate that limit? You take the, bless you, you take the derivative of the top and you take the derivative of the bottom. So I can say, all right, so I have L'Hopital's rule, L hospital, without the S. So take the limit as x approaches 0 of the derivative and then the derivative on the bottom. So what's the derivative on the bottom? What's the derivative of x? 1. What's the derivative on the top? What's the derivative of the sine of 5x? Say it again. Chain rule. So the cosine of 5x times the derivative of 5x, which is 5. So 5 cosine 5x. Now, can we plug in 0 here? Yeah, right? And what's the cosine of 0? So what's 5 times 1? Most of these problems that you get on the exam are actually pretty quick, you know. It's all about just knowing what to do and where to do it. Again, I know if it's been a while for this stuff, it's okay, okay? That's what we're doing here. It'll, you know, tell you what you need to study, what you need to do. All right? Partial derivatives. Calc 3. How do you take a partial derivative? Does anybody, if I want to take the partial derivative with respect to x, how do I do that? Everything else is a constant. It's that simple. So this one's pretty easy. All right? Y'all relax, relax. So, what's that? Yes, you do. All right, so let's take this term at a time. What's the, okay, so we're taking the partial derivative with respect to x. We got a bunch of terms. What's the first one? So I've got x squared y cubed. What's the derivative of that? 2x, no, not 2x, 2xy cubed. That's still a constant. So if it was 4x squared, you treat the 4 like a constant. So this is 2x y cubed. Okay? What about the next one? What's the derivative of this? Y to the fourth. There you go. What about this? What's the derivative of the sine of x? Cosine of x. What's the derivative of the cosine squared? That's actually not a bad answer. Is it? Does the manual list it? It probably doesn't. It might. I don't know, but it probably doesn't. I think we're going to have to break out a little bit of that chain rule, right? We have a pile of junk squared, so I propose it's 2 cosine of x times the derivative of the cosine of x. And what's the derivative of the cosine of x? There you go. What's the last term? What's the derivative of that? No. It's the sine cubed of y. So what's the derivative of that? 0. What's the derivative of 243? Bless you. 0. What's the derivative of 7? So what's the derivative of the sine cubed of y? We're taking the derivative with respect to x, so it's a constant. It's 0. So if I want to pretty this up a bit, I got 2x y cubed plus y to the fourth plus cosine x minus 2 cosine x sine x. Is everybody okay with that? Now, our choices, that still ain't helping us out because it's a little rough. But we can probably do a little bit of factoring. Does anybody notice any common terms here? Not just y. So why don't I factor out y cubed and get this? And are there any common terms here? So why don't I factor out a cosine x and get 1 minus 2 sine x? And as she said, it's D. What do you think? I know, I'm testing you a bit. These problems are scattered and they're meant to challenge you. So I'm just trying to shake the cobwebs off. I'll take it easier on geotech land. So. This is gravel. This is sand.
I think he learned pretty quickly.
But everything's going well, though, right?
Wait, ask us after the first exam.
What?
Ask us after the first exam.
We don't have exams in college. We have celebrations of learning. You're like, oh, now I'm back because now Dr. Mike broke that one out for the 847th time. All right. Take a break from derivatives, do a little bit of integrals. You can look at this and tell me what the answer is. You don't have to do any math. A. How'd you know it was A? The natural log. There's an integral of 1 over x, so it's got to be A. Every now and then, that'll happen on the exam. So not incredibly often, but every now and then that will. Okay? So the answer is A. I didn't even do any math. So. Does everybody see why it's A?
Yeah.
Okay. What's so funny? This one's a little different. This was a little tougher. Does anybody remember how to do this one? I heard you say it. What'd you say? Substitution. Okay. Do you recognize a relationship between, let's say, the cosine and the sine? Does anybody? What's that? For the record, they said there's an X, so that is true. All right. Well, I'm gonna keep it a little easier. No. Well, no. Watch this. I'm going to let u equal the cosine of x. If that's the case, what is du? But it's not cosine squared. That's what I was saying. What? I didn't follow that. I'm sorry. I think we're getting at the same point. But the one point I want to get at, there's a negative there. Bear with me, guys.
Good point.
Oh, man. It's week 2, guys. We're going to get there. What's that? I know. This used to be like 7 hours a day. All right. So here's what I'm going to do. I'm going to go back to my integral, and I've got the integral of the cosine squared of x, and I've got the sine of x dx. Okay? This is u squared. This is what? There we go. All right, so we've got negative u squared du. Now, what's the integral of that? Plus c. Don't forget that arbitrary constant of integration. So minus 1/3 sine cubed of x, or no, cosine. Sorry, it's cosine. Because u is the cosine of x. Plus c. Yeah. You could write minus c, but nobody ever does, so. What do you think? Oh, well, nobody said anything. What's that? You're good? Okay. All right. All right. We only got 6 more questions, guys. We can get this done between now and when class is officially starting to end. Starting to end. Yeah, I know. Again, it's only 1 day a week, so I can mess up every now and then too. Yeah. All right. What is the total area of the region bounded by the x-axis and the curve y equals sine of x between this interval? Okay. The first thing I'm going to do is I need a picture because it's hard sometimes to visualize this stuff. Guys. Oh my goodness. I love this job. All right. Here's the curve y equals sine of x, right? So this is what? Pi over 2 that's pi, that's 3 pi over 2, and that's 2 pi, right? So it's saying what's the total area of the region bounded by the x-axis and this curve between here and the end right here. So basically what we're looking for is that area right there, okay? Now, believe it or not, this example is a test to see how familiar you are with your Casio FX115 ES Plus, because it will do a lot of this integration for you. Now, for those of you saying, oh, this is just the integral of the sine of x from pi over 2 to 2 pi, that's wrong. The reason why is because of the way that that sine and cosine functions behave, you need to split this up into two separate integrals. The area is going to be the integral from pi over 2 to pi plus the integral from pi to 2 pi. Now, for the sake of discussion, what do we get for each of these integrals? What do we get for the first one? For the first one? The answer is 3.
Oh, okay. What do we need to do?
This one's 1. Does anybody else second that? Okay, all right. Now, this is one of those points where you should have your calculator in radians.
You just said it you're confused with it.
Well, the angles are obviously in radians. When in doubt, convert to radians. I did say that.
When in doubt, convert the radians.
Yes. Did anybody else get 1?
Yes, I got 1.
Okay. I forgot the point I was going to make. Look, let me say this. The next one is 2. But you can also figure that out from graphics. See, if this first portion, if the area of this is 1, well, this is just 2 of them. So it's got to be an area is 2, right? Everybody's laughing. What's so funny about that?
We've been in here for an hour and 30 minutes. What do you expect?
I told you this would be a long review. We were only in here for like 30 minutes last time. My goodness.
Yeah, I thought that was kind of setting the stage for the semester.
Oh. All right. Was everybody okay with the last one? Now. I can see the look on some of your faces. Now I want everybody to watch me up here. No, watch me up here.
Watch.
This problem says, what's the solution to the following differential equation? I would argue of any of the math sections that you're going to get on the FE, differential equations is actually one of the easiest, okay? What I mean by that, look in the manual for this equation. I'm not kidding. Look under the differential equation section. For those of you who've had diff EQ, is this first order or second order? Second order. How do you know if it's second order if you haven't had diff EQ? the highest derivative. This is the second derivative, okay? Read the manual. Language, people, language. PE stands for professional engineer. That should be the goal.
Professional during the day.
Everybody relax. Yes, sir. Not in this scenario, no. Guys. We only got 4 questions, whatnot, to get through. After this, so. I'm going to pull the book up as well because I want y'all to see this. Has anybody found this equation? What page? Everybody go to page 36. Oh, that's the specs. Hold on. What did you just say? Okay. Yes. Oh, goodness, go away. Read this, okay? Second order linear differential equations, an equation of this form. Follow it down, go up here, and it flat tells you what the answer is. It says it right here on the manual, okay? So I'm going to follow this equation to the letter, okay? I'm going to follow this section of the manual to the letter. So I have here an equation of the form y double prime plus ay prime plus by equals 0. For those of you who've had differential equations, we take a differential equation, we turn it into a characteristic equation. We solve that characteristic equation. It tells us what the roots are. If you haven't had differential equations, it doesn't matter because it literally just told you to do that, okay? So what we're going to do is we're going to say, all right, go to our diffie-q. Shift F5. Second derivatives become r squared. First derivatives become r. That becomes 16. Then we have to solve that equation. What's the answer to this equation? Like, if I had to solve this, what would I get? Say it again. What's the answer? R equals 4, but it's a double root, right? So R equals 4. Guys, come on. Double root. Okay? So, and I urge you, if you've got your laptop, follow along with me, okay? All right? If you have a double root, and you can follow along, I mean, for those of you who've had diffie-q, you know what the solution is, but that r equals 4 is going to show up here in a second. Just bear with me. All right? For those of you who have your manual, I'm going to take it one step further and literally just plug and chug. So for this equation, we have an a equals 1, b equals -8, and c equals what? 16? Is that right? Did I do that right? So I'm going to just follow this to the letter. So a equals 1, b equals -8, c equals 16. So we have a squared, and we have, what is it? Hold on. Because I just look at it and look at it. So we have a squared and 4b, right? Or no, I did that wrong. No, a is -8 and b is 16. I'm sorry. See? I'm starting to get a little... a equals -8, b equals 16. Let's say I knew something was coming out wrong. So what's a squared? 64. What is 4b? 64, right? If they are equal, what do we have? Do we have overdamped, underdamped, or critically damped? What does the manual say? Critically damped. And if we have a critically damped solution, what's the answer? Well, if we have a critically damped answer, we have C1 plus C2x and e to the Rx. And R, in this case, is 4. So C1 plus C2x e to the 4x. Okay? I'm telling you, if you follow the manual, it will literally tell you what the answer is. Okay? So I don't want you to look at the Diffie-Q problems as impossible. They're really not. Okay? In fact, they're probably some of the easiest problems on the exam. Okay? Everybody okay with that? I know people think Diffie-Q and they think, oh God, you know, it's a nightmare. It's really not, you know. Okay? Everybody okay with this? Okay. All right. Vectors. We have a mixed product. We have a cross product and a dot product. All right, so how do we do this? What's the first thing that we do, the dot product or the cross product? The cross product. How do you do it? Do y'all remember how to do a cross product with the matrix, right? That's fine. You're making a great point. If you all know how to set this up in your calculator, do it in your calculator. Like, you're just going to save yourself some time. If not, you break out the whole rule of Saris. So you do B cross with C. And so what you do, set up I, J, K. Write your B terms, I, 1, 2, 3. C terms, 3, 4, 5, right? Then you write down the first two columns again. So I, J, 1, 2, 3, 4, right? Y'all remember this? Have y'all not done this? How many have never seen this? I'm just curious. Okay, all right. And then what you do is you do all your products this way. So that is, so what do we got? We've got 10I plus 9J plus 4K minus, and then we do all our products this way. So we've got, what is that, 12I plus 5J plus 6K. Did I do that right? So like terms, that's minus 2I. I've got plus 4J minus 2K. Is everybody okay with that? Everybody okay with that? And then the dot product, I would dot this with A. So A dotted with B cross C is, so what do we got? 6 minus 2, 8, 4, 10 minus 2. So this is minus 12, that's 32, that's minus 20. So the answer is 0. What do you think? Not too bad, right? Any questions? I believe in the modes. It's been a while since I've done it, but in the modes, there's a vector mode. And so what you'll do is you store, vector A, vector B, vector C, and then you can take those stored vectors and perform cross products and dot products. Honestly, I would just do that if you don't remember. Let me say this. It is incredibly important that you understand how your calculator works. And if you're good enough to remember all those little nifty functions, you'll do well. Like it'll help you out. But don't think those nifty functions are going to be the difference between you passing and failing. That's not the case. Like if you can't remember them, it's no big deal. Just do this and you'll be fine. Sound good? Do I have a mistake or? Oh, okay. All right. Now, the angle between two vectors. Do y'all remember how to do that? Do you need to remember how to do that? There you go. So how do you find the angle between two vectors? I'm going to make you all tell me how to do it. There's a formula in there. It's in there. Okay. That's for cross products. Now, there's a reason why I'm asking. Is there one for dot products? There we go. What page you find that on? 40. Okay. So what you were doing, so this is a great point. You were referencing cross products and you were referencing dot products. Okay. What my question to you is, which is easier? Dot product. So just do the dot product, okay? So there is something to be said about being somewhat strategic on the exam, okay? So what we've got is a formula that states that A dotted with B equals the magnitude of A times the magnitude of B times the cosine of that angle between the two. Okay? So first off, what is A dotted with B? What is that? Well, it's 4 times 24. It is 12 times minus 8, and it is 6 times 6. So what does that come out to be? Say it again. 36. Okay? Now, how do I determine the magnitude of A? Do y'all remember how to do that? Pythagorean theorem, right? Just in 3 dimensions. So square root 4 squared plus 12 squared plus 6, whoop, be consistent, squared. And what does that come out to be? While you're doing that, I'm going to set up the second one. $14 on the first one. Do I have a second on that? All right. And for B, what do I have? 26. Do I have a second on that? So I propose then that 36 equals 14 times 26 times the cosine of theta. So theta is the cosine inverse of 36 divided by 14 times 26. What does that come out to be? In degrees. What do you think? Again, it's in the manual. And so there's a couple folks I know forgot. If you remember to bring your laptops, because we will refer to that if you've got one, or a tablet or something. Sound good? 2 more questions, and they are pretty quick. What is the determinant of the following matrix? Y'all remember how to do that? What's that? Well, there's two ways of doing it. You can do the cofactor expansion, which I think is what you're doing, or you can do what we just did with cross products. Take that, that, and that. So, what do we have? 2. What's that? I'm writing down the first two columns, yeah. So 2 times 6 times 9 plus 3 times 7 times 7 plus 4 times 5 times 8 minus, and then do those. So we've got, 4 times 6 times 7 plus 2 times 7 times 8 plus 3 times 5 times 9. And do the math. I'll let you all chug that out. It comes out to 0. I have one more problem for you, and then we're done. But does everybody have this, or do you want me to leave it up here for a sec? That's fine, that's fine, that's fine. Everybody good? Last question. Your favorite topic from Calculus 2? Series. All right? Again, it's in the manual. We have the second and sixth terms of a geometric progression. So this is a geometric series. What's the difference between an arithmetic series and a geometric series? Arithmetic, you're adding terms. Geometric, you're multiplying terms. Okay? So I have the second and sixth terms are 3/10 and 243 over 160. What is the first term? So I like drawing myself a little picture for stuff like this. I think it's a little easier. So 1, 2, 3, 4, 5, 6. So this one is 310. This is 243 over 160. Now, let me go to my little handy dandy book here. And let's see if I can find this one. Out here I will do this as well. What's that? Okay. Let's see if I can find geometric. Oh.
It's referred to as a geometric progression.
There we go. Bam. Page 34 or 35. All right? Depending on, if you look here. Okay. So to determine geometric progression, we've got some terms here. So the first term is A, the common ratio is R, the number of terms is N, so on and so forth. So what we're talking about in terms of notation, the terms that they gave us were the second term and the sixth term. That's referred to as L. So what I'm going to do is I'm going to say that this is L2. This is L6. So L2 is 3/10. L6 is 243 over 160. Now, it states that to determine some random term, so if I was determining, let's say, the fifth term, I'd take A times R to the 5 minus 1. Okay? So what I'm getting at is this term is going to be AR to the 2 minus 1. This is going to be AR to the 6 minus 1. So this is AR. This is AR to the 4th. Everybody okay with that? Now, I know that this is 3/10, and I know this is 243 over 160. Oh, that's supposed to be AR to the 5th. Watch this. What would happen if I would divide these two terms? What would happen to the A? It'd cancel out. So if I take L6 divided by L2, that equals AR to the 5th divided by AR, which would equal R to the 4th, right? But then that also equals 243 over 160 divided by 3 over 10. Is everybody okay with that? Is everybody okay with that? Because I canceled the A's. What I'm trying to do is solve for R. What is this fraction? You all have Casios. When I divide this out, what do I get? I get R to the 4th equals what? What is 243 over 160 divided by 3 over 10? Like, what is that? Y'all have Casios. 81 over 16. And so if I solve for R, what do I get? $81 over 16? Yeah. So 3/2, right? Watch this. Watch this. You're going to like this. Take this term, multiply it by 3/2. Tell me what you get. What do we got? If I take 3/10 and I multiply it by 3/2, what do I got? Say it again. 9 over 20? Is that what you said? What about the next term? 27 over 40? Right? Are y'all following with me? What about the next term? $81 over... And what about the next term? Does it work out? So how would I get the term previous? Divide. So what's the division come out to be? I know it's been a long day. They won't all be like this. But I have 2 messages for you. Three. Number 1. This was meant to be challenging, but it's meant to shake the cobwebs loose. I know everybody in here can do these problems. I know you're packing up, but let me say 2 other things. Number 2, if there's any one thing that you learned about the exam and bringing these laptops, what is it? What should you learn how to navigate and use? The manual. 3rd, do the test between now and next Wednesday. I'll see y'all next week.